Hi Statistics 1 students, we are looking again at another week of maintenance, trying to hone our skills in some of the key indicators that we have already covered in class. So the first one is representation of data. We've got to find the mean and the variance of these. So the first thing I'm going to do is find the mean. So I'm going to find the sum of x. So in other words, I'm summing all of this here. Okay, I'm going to sum all of that. And then I'm going to divide it by the number of items of data. You can see that there's 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So that's that. And when I sum them all together, I ended up getting 27, I think. So it's going to be 27 over 10, which should be equal to 2.7. So that's our mean. Now, looking at the variance, we're going to square each of those numbers and add them together. So it'll be like this. It'll be 5 squared plus minus 2 squared plus 12 squared plus 7 squared plus negative 3 squared plus 2 squared plus negative 6 squared plus 4 squared plus 0 squared plus 8 squared. Now, all of that is going to be divided by n, the number 10, right? Which is n. Whoops, that's a bit messy. 10. And then we're going to subtract the mean squared from this, and this should give us the variance. Now, when I do this, when I did this just earlier, I got 27.81, or 27.8 to three significant figures. Oakley dokley. So the next one is a probability question. I've got this chap Sharik. Okay, multiple choice questions online. 3 suggested answers, one of which is correct. Chooses an answer. He first chooses one of the 3 suggested answers at random. Okay, if the answer is wrong, he has a second try, choosing the answer at random from the remaining 2. And if this is wrong, he chooses the remaining answer, which must be correct. Okay, we've got to draw a labeled tree diagram. Okay. Well, he could be wrong, or he could be correct. Or right on his first attempt. Now he's got a 1/3. Assuming he's guessing, I think. Is he? Do we know if he's guessing? Yes, he's guessing at random, right? Answers at random. Okay, so that means he's got a 2/3 chance of being wrong. Now, if he gets it right, he stops. So we can. This branch at the bottom just finishes there, doesn't it? Now, if he selects at random, now he's only got 2 answers left. One wrong and one right. And so he's got a 1/2 chance at this point of getting either the right answer or the wrong answer. And then if he then carries on, he's got a 1 chance of 1 of getting that last one correct. So this should be our diagram. And that seems to be it for this week. That's rather easy, isn't it, really? I'm not quite sure why I didn't give you anything else there. Okay, discrete random variables. So random. Okay, maybe this is why. Okay, here we go. Okay, so a random variable x is the number of attempts that Sharik makes to up until including the one that indicates he's correct, and we've got to draw it up. Okay, so he can. The possible values are, of course, 1, he gets it right the first time, 2, he gets it right the second time, or 3, he gets it right the third time. And the probability that x takes a particular value x here, we can just look at our table that we've drawn up here. Well, we know that getting it right on the first time is 1/3, and then getting it right on the second time would be going this way, wouldn't it? So 2/3 times 1/2. So this is like 2/6 or 1/3. And obviously the last one is also going to be 1/3 as well. And that is our probability distribution table. Now we've got to find, excuse me, we've got to find EX, the expected value. So EX is going to be equal to 1 times 1/3 plus 2 times 1/3 plus 3 times 1/3, and we add that all together. So we've got 1/3, 2/3, 3/3. So I think it's just 2 again, isn't it? Well, which kind of makes sense, doesn't it? Since they're all equally likely and 2's right in the middle. Okay, yeah, should have picked that one up, shouldn't I? Okay. Right. now we're on to permutations and combinations. Okay, 50 members of a club, include both club president, we've got club treasurer. All 50 members want to go on a coach tour, but the coach only has room for 45 people. This is poor planning on the club's part, really, isn't it? In how many ways can 45 members be chosen if both the club president and the club treasurer must be included? Okay, if you've got the president and the treasurer, that means that you have 48 other spaces. And you've got, 48 other people, not spaces. And you've only got, now there's 45, room for 45, and only 43 spaces left. So this is 48, choose 43. This is our answer. So that gives us 1,712,304 different ways we can select. Okay, the 45 people. Right, now the next one is we've got some boys and girls, 6 boys, 4 girls, they're standing in a line, and if all of the 6 boys stand together, so we've got boy, 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 and then we got our girls. So what we're going to do is we're going to treat these guys as one, and therefore we've got 5 items. So there's 5 factorial ways of arranging the items, but then within each of those ways, because there's 6 boys in a row, we can arrange those 6 boys in 6 factorial ways. So if we go 6 factorial times 5 factorial, this should give us 86,400 different ways. Now what if no girl stands next to another girl? Okay, so what I would do in this situation is I'm going to say, alright, here's my boys, I've got 6 boys. Okay, and we're going to use them as the blockers to stop girls from being next to each other. So we've got a position here, we've got a position here, 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 here. Now, in arranging the boys, we've got, again, 6 factorial ways of arranging the boys. Now, we've got to start thinking about where we place the girls, right? So the girls can go into these spots here, and you can see therefore that there are 7 spots, aren't there? 7 spots, right? So we've got the 4 girls, and the girls have got to go into those 7 spots. Now, what are the ways that we can arrange them? Well, we've got 7 spots and we're choosing 4 girls, so there should be 4 ways, but not choose 4 ways because we should be thinking about permutations here. So because the girls are not exact copies of each other, right? They're 4 different girls, so it should be 7p4. Or alternatively, if you don't like that, we could go again. We could think of it like 6 factorial for the boys, and then for the girls, we could go, well, there are 7 options for the first girl, times 6 options for the next girl, times 5 options for the next girl, and then the last girl's got 4 options, and those are all of the different options, which is, of course, 7p4. So in total, this is giving us, I don't know, what is it giving us? I didn't seem to write the answer down for this. So 6 factorial times 7 times 6 times 5 times 4. So this is giving me 604,800. 604,800. So I think it's this. Okay. Now moving on, we've got a discrete random variable binomial question. So the old binomials. We have 4 fair-sided dice. 4 dice, and they're marked with 1, 2, 3, 4, 5, 6. Find the probability that numbers shown on 4 dice add up to 5. Okay, how are we going to get that to happen? Well, you could go. What are the options here? I think you have to have 3 of them having 1, don't you? 1, 2, 3, 4. I don't think you can have a 3 because then you'd have to have a 0, right, on one of the other dice. So this is the only way of arranging it. And of course, you can arrange it 4 different ways, I think. Oh, like this, right? Those are the different ways that you can arrange it. Okay, so it's 4 ways. And each way, what is the probability of each way? Well, obviously, to get a 1, it's a 6th chance. Getting a 1 is a 6th chance. Getting a 1 is a 6th chance. And getting a 2 is a 1/6 chance. So we can just simply write that as 1/6 to the power of 4. Now, each of those options is exactly the same. So we're just going to multiply that by 4. And this should give us 1 over 324. Last question for the day. We have 4 fair-sided dice and marked again, blah, blah, blah. We throw them on 7 occasions. Find the probability. Okay, so that last one was not a binomial. I don't know why it's stuck in here. Okay, find the probability that the numbers show on the 4 dice add up to 5 on, now here's the binomial, on exactly 1, 2, or 7 occasions. Okay, so we're throwing it 7 times. Now, when we're doing a binomial, we're going to do this. We're going to go, so this is 1 occasion. How do you spell occasion? Oh, there it is. 1 occasion. Now we write this as 7 choose 1, and we're going to times that by the chance of success, which we found in the previous part of the question to be this. Now we want 1 success, and therefore we're going to times it by 323 over 324. That's a chance of failure, of not getting it, and that will be 6 times. All right. So that will give us the answer to the first one. Okay. And what about on 2 occasions? And obviously this will be 7, and we want 2 successes. So now it'll be 1 over 324 to the power of 2. And we're going to multiply it by the failures will be, how many times will we have a failure? Should be 5. Okay, and then 7 occasions. That means it's success on every occasion. So we would go 7 choose 7. So there's one way of doing that. And we've got 1 over 324. And that will be to the power of 7, because every single time we do this experiment, we're getting a success, which means that we get no failures. So this will be to the power of 0, or just we times it by 1. Okay, now I presume you have to add all of these together. So chuck this into your calculator. So choose 1 times 1 over 324 times 1 323 over 324 should be to the power of 6, and then plus 7 choose 2 times 1 over 324 to the power of 2 times bracket 1 over 324 to the power of, what do you say, 5 here. And then the last one is 1 over 324 to the power of 7. Now, I'm getting as my answer to, so I sum all of these, I'm getting 0.021, I think it's 212 or something. Hopefully I've done that correctly. I may have made a slight error, I don't know. I didn't write the answer down properly for this one. Let me know if I have. But I think that's the general gist of what we need to be doing here. I hope it makes sense. Let me know if you have any questions though. Oh, you know what? I've just realised I made a mistake. I didn't read the question properly. 1 or 2 of the 7 occasions. So we actually don't need 7 occasions. that kind of makes sense. I'm not sure why. So let's go back to the drawing board on that one. Sorry about that, team. So it should be 7 times 1 over 324 times 323 over 324. Whoopsie. And that's to the power of 6. Plus 7 choose 2. times 1 over 324, and make that a squared. It always pays to read the question. Times 3, 2, I'll put this in brackets as well. 323 over 324, and that will be to the power of 5. Okay. Ah, there we go. Okay. Very close anyway. It doesn't make... I must have stuffed up in the first time because I've now got an answer that's a little bit higher. But anyway, 0.0214 is my final answer there. Okay guys, I guess that's a good lesson. Read the question carefully. Take care, see you next time.